Assalamu alaikum, dear students. We have selected two question ones from paper 5, uh, and for convenience I have written all the details, so most of the time the focus will be on the screen and you will go through all the details that I have written by solving those two questions. So we'll discuss those two questions one by one. So let's begin with the uh, one of the questions that I have selected for today's discussion. First, you quickly go through the question itself. This is typically uh, what they provide in question 1. For example, they are informing us about two students who are having discussion about an experiment in which the air inside a bell jar is gradually removed and the sound of the ringing bell inside the jar is heard to decrease in intensity during this process. One student suggests that the frequency f of a sound wave and the pressure P are related by the equation F is equal to K P square, where K is a constant. So you are required to design a laboratory experiment to test this relationship. Now, the details that follows on this page is not very important for you because you already know how to follow the steps to respond to this question. So if I move to the next page, this is the page on which suppose this is a student's response in which the student has drawn this picture of the bell jar. This is the bell jar and inside there is a bell. This bell is obviously connected to a circuit here. This is the switch. You should label it as a switch. This is the wire connected to this switch. And this is a vacuum pump connected to this with a pressure gauge connected to it. So obviously you will use this apparatus, you will describe in this experiment that will use this apparatus to decrease the pressure gradually in this bell jar, and every time we sound this bell, the sound is recorded by this mic, and the shape of that signal appears on the CRO, which is used to find the frequency of this sound. Before you make this picture, the first step in recording your response to question 1 is always defining the problem. So what exactly are we doing in this question is written here. In this experiment, we are going to investigate how frequency of sound varies when pressure is decreased by removing air from a bell jar. Frequency is independent variable, P is dependent variable, and with temperature as a control variable. There is one more control variable possible here, and that is the frequency of the sound generated. So throughout the experiment, the frequency of the sound will be kept constant. I mean, you will not change, and the frequency will change as a result of decrease in pressure, but original sound will have the same frequency. Then you will describe this picture that you have already made in this space provided for it. The bell jar has initial uh, pressure P naught noted from the pressure gauge. The bell is sounded using the circuit, and the frequency of the sound is calculated using the apparatus of the uh, using the appearance of the signal from the CRO screen. You will also describe briefly how you calculate frequency using the time-based setting. First, you calculate the time period of that sound. For this, you need to recall what you learned in AS. When you learned how to calculate the time period of the signal, and then using that time period, you calculate the frequency. Moving on to the next page, a loud sound uh, a loud sound is recommended, so it can be recorded easily by the mic, and a signal appears on the screen which is of reasonable height. The pressure is reduced using the vacuum pump, and the frequency of sound is calculated again from the CRO. That means you will repeat this measurement 6 times. Temperature is checked for each measurement, and a correction is made in case of any change. The distance of the mic is kept at the the distance of the mic should be same from the bell jar. That should also be uh, one of the control variables. Pressure should be reduced in reasonably large gaps to have larger or significant change in frequency. This is one of the suggestions that could come to your mind while you are responding to a question like this. Then uh, you have completed two parts here. I mean, this is where you have completed the data collection part. Now this is the data representation part starts here. A graph plotted between f along y-axis and p square along x-axis, and this will give us a straight line through the origin, because from the equation it can be easily inferred that there will not be any y-intercept, so this will be passing through the origin. The gradient of this line uh, is the constant k. If I go back to the original equation, this is the equation. So you must learn that if I keep f along y-axis, p square along x-axis, there is no y-intercept. So this equation represents a straight line through the origin. And finally, finally, one precaution that you must mention, which will bring you 1 mark. One precaution could be to wear goggles so that if a glass jar shatters, your eyes are safe. So this is question number 1. Another question that I have selected for discussion looks like this. So once again, go through this question first, try to understand what this question says. A student has a Hall probe to investigate the magnetic flux density due to a U-shaped electromagnet as shown. So this figure is given this time. Point P, this point P is equidistant from the poles of the electromagnet, and distance P is the vertical distance between P and the top of the electromagnet. The magnetic flux density is B at point P. It is suggested that the relationship, look at the relationship they have given, B is equal to N K N I E, this is exponential function, E minus alpha P, where N is the number of turns on the coil, I is the current in the coil, and alpha and K are constants. So design a laboratory experiment using Hall probe to test this relationship. So the rest of the detail, as I said earlier, is not very important, because we'll follow the same pattern. We'll start with defining the problem, then we'll make a figure, and that will cover the part called uh, data collection, and then comes data representation, and in the end we write the precaution. So we'll follow the same pattern in this question as well. So let's begin from the question, from the this part, page 2. So let me first go through this part, which is known as defining the problem. In this experiment, we are investigating the variation of magnetic flux density with the distance along a vertical line above the top of the center of a U-shaped electromagnet. So you have described the problem briefly, rephrasing more or less the same words they have given. Side by side, you have mentioned that P is independent variable, B is dependent variable, while N, which is the number of turns in the coil, and current in the coil, both are control variables. So you will keep them constant throughout the experiment. Then you go to the figure, and Look at this figure. You are going to describe this, uh, mentioning all the quantities you are measuring here, and detailing all the apparatus you have used here, and give them reasons why you have used each set of apparatus here. For example, this is a U-shaped magnet and you have clamped it on a table. Obviously, this should be clamped so it remains fixed in its position throughout this experiment and doesn't fall off. And with this coil on one side of this, you have connected a wire, and this wire has at least 4 different components connected. This is a variable resistor, then it comes here the battery, you have labeled it here, it's mentioned battery here, then you have a switch connected in series with this, and then finally an ammeter here, because you need to know what current is flowing and you need to keep it constant. In case there is any change in current, you can bring it back to the same value with the help of this variable resistor. On this side, you need to have a vertical stand here with which you have uh, fixed a meter rule, so you can read this distance. But before you read this distance, you need to have a fixed reference point here. So you have a small cardboard paper on which you made this point. This is important because all the distances are measured above this point, as it was mentioned in the statement of the question itself. So this is a piece of cardboard you have pasted on the meter rule, and then you carefully read all the distances above this reference point. So P is one of those variables. So all this is now detailed here in this description, which is called the method of data collection. The electromagnet with the reasonably large number of coils N is clamped onto the table. The circuit contains an ammeter to measure I and a switch to open after each measurement. A variable resistor is also used to keep current constant if there is any variation. A battery uh, is provided for a steady voltage. So all these things you have mentioned in the picture as well, and you have provided a detail here and their purpose. Then a stand with a fixed vertical meter rule and a cardboard with a mark in the center of the two top edges of the magnet. Distance P will be measured above this point using the meter rule. For subsequent measurement, the Hall probe is used to measure B for each value of current. So you will move the Hall probe along that distance, and the value of B will be recorded for each distance. So this completes the part we call method of data collection. Then comes the method of data representation, and that is always about the graph. The graph is plotted between ln of B along y-axis and P along x-axis. Why ln of B? If I go back to uh, that equation that was originally provided, look at this picture. This equation has B related to all these values which are constant, and the variable is actually this P, but this appears as a exponent in this exponential function. So whenever this happens, we take natural log of the two sides of the equation to get rid of this exponential. If I take exponential of both sides, this is what I get. Look at this. Ln of B is equal to ln of k and I minus alpha P. So this becomes an equation of straight line which will have a negative gradient, which will be equal to alpha, of course, because you are keeping this P along y-axis. This P is along x-axis because that is your independent variable, and ln of B will be used as your dependent variable, which will be taken along y-axis. So let's go back to, yes, the last page. So all this detail is provided here. So using uh, this idea that I have described there, alpha will be the gradient of this, y-intercept will be y-intercept will be ln of k and I. Using values of n, I and k, n and I, k can be calculated from y-intercept because y-intercept is ln of k and I. One precaution that we mention here is do not touch the wires with bare hands. Naturally they will be uh, hot because continuously current will be passing through them, so it's important to save yourself from that. So wear gloves is a suggestion you can mention here. A few other ideas that instantly come to mind, which they accept in additional detail, and each point that you add here or during this description will bring you 1 mark. For example, a large current is recommended, so strong B is created, so it can be easily measured. P should be varied through small values, so you have at least 6 values over a very small distance, because it's not several centimeters distance over which the variation takes place. Coil should be made using thick wire, so it doesn't heat up, it has small resistance. So out of this total, this description brings you a reasonably good marks if you cover all these points in this arrangement. So dear students, we have tried to give you a flavor of what question 1 looks like and what is the typical response of this, what is usually given and what they expect from you. And every time you need to understand how to break up that response. It begins with defining the problem, then comes the method of data collection, which covers that part in which you make the diagram and describe it. Then comes the method of data representation, which covers the graph and what it will give you if you do some calculations using it. And finally, there is a precaution. So I have tried to give you all this detail, and I will also share all this written specimen. So you go through this carefully any number of times, and then you will finally grasp the idea of how to respond question 1. Thank you.